All right, let's jump right in. When we think about software testing, we usually picture some kind of final safety check, right? Like a quality inspector giving a new car a quick once-over. But what if I told you the very best testers, they aren't inspectors? No, they're detectives. And their job isn't to admire what's been built, it's to find where it's broken.
So that leads to a really basic question. What is the true goal of software testing? Now, you probably have an answer ready to go, but I'm going to tell you the most common answers, the ones you hear all the time, they're just plain wrong.
See, here's the split. You've got the common belief over here, which is that testing is all about proving the code works. It's about building confidence. And then you have the detective's truth. Testing exists to find out where the code breaks. And believe me, this isn't just semantics. It's a completely different mindset, and it's what separates kind of useless testing from testing that actually makes software better.
And this common misconception, it's a huge problem. It plagues even really experienced development teams. Most people are just starting from a flawed definition of testing, and when your foundation is cracked, you're going to end up with buggy software. It's almost inevitable.
I mean, you see these definitions everywhere, right? Testing is to demonstrate that errors are not present, or it's to establish confidence. Well, according to Glenford Myers, who's a pioneer in this field, these definitions are completely upside down. Think about it. If your goal is just to show that a program works, you're going to subconsciously pick test cases that are likely to pass. You're not really challenging the code, you're just trying to confirm your own biases.
So, to actually be effective, we have to flip the script entirely. We need to adopt what you could call a destructive mindset. It's about looking at the software not as this precious thing to be protected, but as a suspect in an interrogation room. And our job? Our job is to find the evidence of its guilt.
And that brings us to the one correct definition of testing, the process of executing a program with the intent of finding errors. That one word right there, intent, it changes the entire game. You're not just running the code anymore. You are now actively hunting for failures, and your whole approach has to shift.
Now, Myers himself knew this isn't easy. He said it's a destructive, even sadistic process. And that's because it goes against our very nature as builders and creators. It feels weird, maybe even wrong, to try and break something that you or your teammates just spent weeks building. But that's exactly why it is so valuable. It forces you to use a different, more critical part of your brain.
And this all leads to a conclusion that honestly feels pretty radical at first. So, in this new wave thinking, what's a successful test? Well, a test that runs perfectly from start to finish and finds 0 bugs, that's actually an unsuccessful test. It failed its mission. A truly successful test is one that uncovers a new bug, one nobody knew about. That's a success, because you just made the software better by exposing one of its weaknesses.
Okay, so if we're hunting for errors, where do we even start looking? I mean, we can't test every single possibility. That's just not going to happen. We need a strategy. We need to know where the bugs like to hide.
And the reason we need that strategy is just simple math. Even a really basic program can have billions or even trillions of possible input combinations and paths through the code. So exhaustive testing isn't just impractical, it's literally impossible. The whole game, then, is about choosing our tests very, very wisely to get the biggest bang for our buck.
And this is where the detective work gets really clever. There's a technique called boundary value analysis, and it's one of the most powerful bug hunting tools there is. The core idea is simple. Errors don't usually happen in the middle of a valid range. They tend to cluster right at the edges, at the boundaries. And so, that's where we're going to focus our investigation.
So here's the playbook. For any input that takes a range of numbers, let's say 1 to 100, we test the ends, 1 and 100. Then, and this part is absolutely crucial, we test just beyond those ends. We try invalid cases like 0 and 101. We do the same thing for, say, the number of items in a list, or even for the program's output. We're basically walking the fence line, pushing on it to see where it's weak.
So let's take the classic triangle example. A program takes 3 numbers and tells you if they can form a triangle. You could test it with 3, 4, and 5 all day, and it'll work. But a boundary detective, they'd immediately test the edge case, 1, 2, and 3. Why? Because here, the sum of 2 sides equals the third. It's a flat line, a degenerate triangle. A super common coding mistake is using greater than or equal to when it should just be greater than. This boundary test is designed specifically to sniff out that exact kind of error.
But of course, no investigation gets an infinite budget. We don't have unlimited time or money, so we have to figure out when our hunt has been productive enough and when it's time to stop.
This is honestly one of the hardest questions in all of software engineering. Since we already know we can never find every single bug, when do we say we're done? Just stopping when the deadline hits? That's a terrible metric. And stopping when all our tests pass? That's even worse. It just encourages us to write easy tests that don't find anything.
And here's where Myers gives us another brilliant, totally counterintuitive solution. If the whole point of testing is to find errors, well then the best way to know when you're done is by counting the number of errors you found. I know, it sounds crazy. You might literally say, we will not stop testing this feature until we have found and fixed at least 15 bugs. You set a bug quota.
The reason this whole bug quota idea actually works is because of a very real phenomenon in software: errors cluster. The probability of more bugs hiding in a piece of code is directly proportional to the number of bugs you've already found in it. So finding a bug isn't a sign that you're almost done, it's a flashing red light that this part of the code is probably a mess, and there are likely a lot more bugs hiding right nearby.
So when you start to put all these pieces together, you see that good testing isn't some mechanical, boring checklist. It's a real art form. It's the art of finding flaws.
So let's just recap the detective's rules here. 1. Always define what you expect the output to be before you run the test. Otherwise, your brain will trick you into seeing what you want to see. 2. Get someone else to test your code. You're just too close to it. You're too biased to be a good detective of your own work. 3. Don't just check that the program does what it's supposed to do. Make sure it doesn't do what it's not supposed to do. And finally, always remember, where there's one bug, there are probably more.
And this is really the main takeaway. Far from being this boring final step, good testing often requires more creativity, more skepticism, and just more raw intellectual power than designing the software in the first place. It is a deeply challenging and creative job.
So that leaves us with one final question to think about for your own projects. Are your tests actually designed to challenge the software and find its weak spots? Or are they really just there to make you feel good about what you've already built? In other words, is your process actually building confidence, or is it just confirming your biases?